GAMMA.DIST function. GAMMA.DIST function returns the gamma distribution, which is a two-parameter continuous probability distribution. The syntax for the GAMMA.DIST function is GAMMA.DIST of x, gamma alpha, gamma beta, gamma cumulative, where x is the value at which to evaluate the function, alpha is the shape of the gamma distribution, and beta is the scale of the distribution. Cumulative is the form of the function where we choose the probability density function as the form. In this video, we'll generate the dataset of the probability density function of the GAMMA.DIST function. Here we have a spreadsheet where the values of x is from 0 to 15. And our value for a is from 1 to 10. So copy, and we use data validation, list of items, and paste it. So our A alpha has these values 1 to 10. For beta, it will be 1 to 3. So data validation, list of items 1 to 3. So these are the values to choose from for beta. So we choose 1 here for alpha and 1 for beta. Next, now that we have all this filled up, we can use the array formula to generate the dataset. So gamma dist of the x values, gamma alpha, gamma beta, gamma cumulative, which is 0, enter. And here we have the trend line where we can choose our values to 2, we can change it to 5, so whichever is possible, whichever value you like. Then we can use the equivalent formula, which is equal to x to the power alpha minus 1 times e to the negative x over beta all over beta to the alpha times gamma of alpha. We start with the denominator, which is array formula, beta to the alpha. So 1 over beta to the alpha, beta to the power alpha, times gamma of alpha. So that's the denominator part. Next, we continue. We begin with the first part of the numerator, which is exponent negative x over beta. So exponent, and that's negative x, so minus x over beta. And we'll generate the trend line for this. To check the trend line, and we use polynomial to the highest degree. Now we have a trend line. Then we can complete the numerator part. So the other part of the numerator is x to the power alpha minus 1. So that's x to the power alpha minus 1. Alpha minus 1. That's x to the power alpha minus 1. This is x, this is x, so x. That's x to the power alpha minus 1. They are now on the same trend line. So we can make some changes. If you choose 3 for beta, if you want to choose 8, so if you decide on 2, so if you want 4, next we check if our trend line and our data sets are correct. We start with the example values. In the case of the Google Sheet, here you have at x equals 5, alpha is 3.14, and beta equals 2. So we will add 3.14 to alpha. So alpha, that's data validation, you can add 3.14. Say. So in this case, beta equals 2. We'll go back. So beta is 2, alpha is 3.14, and x equals 5. So these values. We will check these values. So we change this to 3.14 and beta equals 2. The value should be 0.1276550.316, and it is 0.12655.0316. Then we look at the example of Microsoft's help support. Here we have x equals 10. So we'll change this to our 10 will be changed it to 10. So this is 10. Enter. So we'll mark that 10. And at x equals 10, alpha is 9 and beta is 2. So alpha is 9 and beta is 2. So our value for gamma distribution is 0.0326391.3. So 0.0326391. It should be 0.0326339. So this value matches to our results, 0.0326339. This completes the use of array formula, data validation, and gamma in, in generating the data set of gamma distribution or the gamma probability density